Today we're talking with Frank Webb, who leads engineering and program management at Edison. And Frank, topic today, talking around quality. So be interested from your perspective, what does quality mean to you and how are your functions supporting the end result of Edison providing a high quality product for our customers?
Yeah. So when we talk about quality, obviously we're talking about product quality, and even a good manufacturing organization that never ships a bad product still cares about internal quality because that drives cost, right? Rework and scrap and things like that. And when we're talking about it in the context of a manual assembly operation, which is usually a big flavor of what we're doing, we're talking about making a process and interlocks in the phases of the production process that can essentially it reduces the opportunity for an operator to make a human error, and increases the chance that we're going to catch that human error early on in the process before we add a bunch of value. So that comes down to a lot of sequencing, the high risk things. If you can move them earlier in the process, obviously, then you'd like to do that. So sometimes it'll be offline subassemblies. So we'll have a kind of a feeder, sort of a line system where high risk, maybe electronic modules or highly sensitive components are assembled separately, and then fed into a final assembly. And also it comes down to the way that you're delivering direction to the operator and what you're asking the operator to do. An example that actually that I've seen a couple of times is if you've ever heard of the red bead experiment. It's kind of a thought experiment where you give a team of folks, usually it's a consultant that does this, and it's kind of a flashy thing, but they give you a little scooper to pull out red and white beads out of a bucket. And you scoop it out, and then the number of red beads in your bucket or in your scoop is your failure rate. And so you'll kind of give the team a whole task to how do you reduce it, and is it the way you shake it? Do they weigh differently? And the moral of the story is the red beads and the white beads are physically identical. It's just a color, and you're not giving that operator a chance or any tools to control that. So if you think about it that way, that's obviously a highly abstracted kind of a straw man argument. But you got to think of the way that you're presenting the task to the operator from those grounds, right? What does the operator really have control of that can affect quality? And how do we take things that they can't control that could affect quality and control them some other way? And that's usually where you end up with high automation, right? Where the operator may install something in the wrong orientation. So we're going to give them a jig that's pressed with a machine, right? And it does it so the operator can't make that mistake. Well, if you're looking at this from the context of an assembly operation that is lower in volume and doesn't justify that kind of capital assembly, you start to think of other ways, visual guidance, maybe vision systems that can, at a relatively low cost these days, can help detect a misaligned part, or sometimes it's the way the tools are laid out. Is the operator reaching from here to there? Are they walking? Are they getting distracted in between the operations? And intelligent assembly of the process can really reduce the operator's chances of making a human error.
Yeah, and that's such an interesting point where especially people who might come from the higher volume background, right, which is typical for the automotive industry and also some other adjacent industries, think, yeah, when you think quality, when you think control, you think automation, you think remove the possibility of something being incorrect. It sounds, and I appreciate your thought elaborating on this. It sounds like, yes, that philosophy drives us, and we're working in that direction of, hey, how can you remove ways in which this can be assembled incorrectly? But there's a limit there, right? Because we're not going, part of this capital light philosophy that makes sense for low volume production is we can't invest millions and millions of dollars on highly automated systems that make it impossible for something to go wrong. So we need to be able to bolster that with creative or intelligent thought processes and intelligent manufacturing processes for how this actually comes together. Can you expand on that?
Yeah. So are you thinking like I guess when I think about that, I think about it really comes down to fixture and process design, and also it really comes down to feedback from the operator. So that's the part where if you have a really integrated sort of a culture in the organization, and you really involve the operators, the folks that are going to be doing the work and assembling the product in the product launch process, and you time that product launch process intelligently so that you're expecting a stop and rethink process at numerous phases along the production process, It oftentimes, at first glance, if you look at that program timeline, it feels like we're starting and stopping, which is generally never something you want to do in a production operation if you can avoid it. But we're not really starting and stopping. We're shifting focus. We're doing a build and then we're learning from it, and then we're doing a slightly larger build and we're learning from it, and we're doing a slightly larger build than that before we get to a steady state operation. And that gives us time for both the product to mature. Sometimes those initial units make it out in the field somewhere, and engineering wants to make a change. The product isn't performing, or there's an optimization we can make, or a cost optimization sometimes. But also we're optimizing the process, and that comes down to the tools, the fixtures, the equipment, the instructions we're providing, the sequence of those operations. But also you're tuning up your training program for the operators. You're learning where the operators are giving you feedback that, hey, I keep messing this part up, or this is requiring a lot of focus. It seems fiddly, right? That's one of the worst things you want to hear is fiddly in a manual assembly operation. But if you have that context set in the right way up front, and you plan the program around that, you really it's like slow down to speed up, right? You're going to do an intentional operation. You're going to intentionally learn from it. You're going to do another one, and you're going to intentionally learn from that. So usually in our program launches, there's 3 or 4 alpha or beta phase builds that build on each other before we get to something that's actually as robust as we want it to be.
So it sounds like this thought process is critical to execute those upfront high change engineering builds successfully. But then maybe even more importantly, it's critical to provide the fuel and the learnings that allow us to operate at rate as we scale up and really be humming and delivering. I mean, not that we're getting to these high volume limits, but when we get to the rate of what we're doing, whether it's hundreds or low thousands or whatever, that sets us up for success by learning from all those early builds.
Exactly.
Maybe the last topic I'd be curious to get your thoughts on, this idea of product-centric quality, right? So especially, I mean, obviously Edison as an organization, we cover a wide range of products from small components up to full vehicles and upfits and such. But for these types of build, these capital light, these lower volume builds, can you talk to the importance of understanding that each product is unique and accounting for that intentionally when putting together a quality plan?
Yeah, each product is absolutely unique. We do things that range from a junction box up to a full vehicle upfit, or sometimes powertrain swaps and things like that. So every product is different, but the thought process that goes into it can't be. The thought process has to be looking at it from the product perspective and also from the people perspective. So if you look at it from the perspective of the operator and the product, we think, how could these two work better together? And so when we give DFM feedback, that's where a lot of it comes from. There's obviously the low-hanging fruit stuff like, commonize your fastener drive types, right? That's something that any manufacturing engineer is going to be familiar with. And they see multiple drive types, they're going to get a little bit stressed out. But if you start to think about that a little bit differently, you're going to think about maybe 2 products that can't fit in each other's places, but visually they're not very distinct. That can drive inefficiency, even if it won't assemble the wrong way. The operator having a visual, one's green, one's blue sometimes, or maybe we can reorganize something to have a different feature on top. So it's inherently, intuitively obvious to the operator which one I'm grabbing in what order. I grab them with a tab, and then I grab them without the tab, even if the tab isn't necessarily a functional tab. Something that's visually distinct to the operator is part of the product. And if the product can withstand something like that, we try to think a little bit creatively. Sometimes it's just the color of the insulation on something that can help make it the learning curve for the operator getting really into the groove with an assembly step. Make that shorter, right? That something is visually intuitive to the operator, and then that's part of the product, right? The product needs to be intuitive to assemble within reason, obviously, right? We don't want to go and completely reassemble everything to be Legos, but there's identifying those hot spots during the initial builds, and we need to think about this product, and a small change can really not just drive efficiency and reduce errors and cost of quality and all that, but can make it so that the operator doesn't feel like the operator doesn't have to put a ton of effort into the learning curve. The learning curve comes naturally, and then you get that kind of the flow state of, all right, now we can take a step back. We're not stressing out about which part goes in what order. Now we can think about, how do these actually fit together? How am I being presented with the parts and the tools? And how is it being articulated to me in work instructions? And how can we really tune that up?
Yeah, thanks. That makes a lot of sense. And there's a ton more information. We can get layers and layers deeper, which I'm sure over the course of this capital light assembly series we will. But given the short nature that we're trying to target here, I think that we can wrap it up for here. So Frank, really appreciate it. I think this is a good overview of what quality looks like, how we think about quality for low volume capital light assembly. And yeah, appreciate you joining for the conversation.
Absolutely.